Thank you very much for everyone's time in answering those questions. It's important to note that this session will be recorded and we'll make it available on the NECTR, the National Center for Transit Research website. Today what I'd like to do is start off by introducing our speakers. We have a series of speakers, as you can see from our slide. We have Kevin Webb, the co-founder and principal of Conveil, and David Emery, also the co-founder and principal at Conveil, with Bibiana McHugh, the IT manager of GIS at TriMet's, and Mei-Ling Richardson, also a GIS planner with TriMet. Conveil is a consultancy born out of the OpenPlans Transportation Technology Group and is focused on providing support for OpenTripPlanner and related open transportation projects. Conveil specializes in open data and open source software for the transportation sector. David Emery is the principal with Conveil and one of the founding developers of OpenTripPlanner, now focusing on building open source tools for sustainable transportation applications. He has particular focus on multimodal routing and trip planning, transportation network analysis, data management and visualization. Prior to Conveil and OpenPlans, he was a principal transportation planner for the Atlanta Regional Commission, a member of the Policy and Intermodal Planning Group, serving as a principal transit planner and staff resource to the Regional Transit Committee, Atlanta's regional transit policy and coordinating body. Kevin Webb, also a principal at Conveil, previously worked on OpenTripPlanner and other tools under the OpenPlans umbrella. Now he and others are advancing open data ideas and developing new tools at Conveil. Our other two speakers are from TriMet. Bibiana McHugh has worked in TriMet's IT department since 1997 and currently leads a team of innovative web developers and analysts. After collaboration with Google for the first release of Google Transit in 2005, she helped pioneer the now worldwide standard General Transit Feed Spec. Bibiana initiated the development of the OpenTripPlanner and continues to lead and support open source software and open data initiatives, including OpenStreetMap and government partnerships. Mei-Ling Richardson, also with TriMet, has managed and maintained spatial data in TriMet's enterprise database for the last 15 years. As an analyst, she has worked extensively with developers and end users on software design and support, and played a key role in the development and now ongoing maintenance of the Call Taker and Field Trip modules, which will be presented today. So with that, I'm happy to hand over the presentation. I believe first we're going to hear from Kevin and David about some of the technology and things they've been doing. Over to you, Kevin.
Great, thank you, Martin. So as part of the first section of today's presentation, I want to cover some of the work that my colleagues and I at Conveil have been working on, extending OpenTripPlanner in the context of multimodal transport analysis and modeling. This is a project that we've been working on together for a number of years now, and it's something that David Emery played a really key role in kind of bringing to the organization. We've initially started working on this together under David's leadership. And I want to share kind of one of the things that we've been working on over the last couple of years has actually evolved into a product platform that we're now starting to deploy as well as Conveil and as an open source extension to the OpenTripPlanner platform. And just to give you a quick background of this, I want to start off, for those who aren't familiar with OpenTripPlanner, and talk a little bit about how we started this work and kind of how it began as in trip planning and then what that's evolved into from analysis. And just as I think was mentioned in the introduction here, all of us, David and I and my other colleagues at OpenPlans, began our work at OpenPlans, working on OpenTripPlanner, and this is a project that was really championed by Bibiana and her colleagues at TriMet. This is something that they brought to OpenPlans as an idea to build an open source multimodal journey planner that allows people to combine the transport network and view it as a whole system connecting bike and ped and transit and cars together in a holistic view to provide multimodal journey plans to the public. This is now powering TriMet's public journey planner. It's also being used by a number of other applications around the world. It has applications in the millions of users they're using OpenTripPlanner behind the scenes to do the routing. This is an example of an app on the iPhone and Android platforms called the Transit app. Has a couple million users around the world, works in dozens and dozens of cities where GTFS is available, and currently uses OpenTripPlanner as the routing platform behind the scenes, in addition to providing data and real-time transit information, using GTFS real-time as an open data standard to bring that together. This is an example of how OpenTripPlanner as a customer-facing or rider-facing tool has evolved and been used. But what's interesting in the context of today's conversation, the thing I want to talk about is, in terms of how we're looking at it in a planning and analysis context, is that fundamentally the data that powers OpenTripPlanner and powers transit information platforms generally, this general transit feed specification that was mentioned in the introduction, this data set is actually a really rich model of transport networks that allows us to do a lot of different things and ask a lot of different questions, not just A to B queries about how to get from location to another location using the transport network. We can actually use this data as an input to understand how the transport network works in some really fundamental ways, and at a level of granularity that we've traditionally not been able to do, at least cost effectively. Historically, a lot of transportation modeling efforts have relied on one-off data collection efforts to kind of create a representative snapshot of a transit system, and that snapshot is expensive to create, and often can't be created at the kind of complete level of granularity that is expressed operationally, just because it's too time-consuming to deal with. But what's interesting, because we're producing GTFS data sets now for consumer applications that actually represent the operational kind of situation of the transit system very precisely, those data sets are being updated already to support consumer applications. We've seen an opportunity to then consume that data and use it in an analysis context. And it turns out that the same analysis that we're doing now, or the same type of analysis that we're interested in doing, leverages the code and the kind of ideas and concepts that are used in OpenTripPlanner to provide individual trip plans and multimodal routing for customers. And the reason why this is possible in OpenTripPlanner and using GTFS is, if you look at the slide here I've just brought up, this is a picture of the model that we're creating inside OpenTripPlanner to actually allow people to navigate a city. And this is showing basically the kind of a schematic of how the Lexington Avenue line in New York City connects to the street network, and how these basically the street data, which is coming from OpenStreetMap and as a routable multimodal network that allows people to explore the surface transportation either as a pedestrian, as a cyclist, or as a driver, connects down under the street into the transit system, and where GTFS represents a scheduled system that connects between stop locations. And this model is what allows us to get you from one street corner to another using the street and transit network combined. But it also is an extremely useful model of actually how the city as a whole is functioning. And we can use this model that we're building inside OpenTripPlanner to ask a number of different questions and to explore the city in different ways. And in the context of OpenTripPlanner Analyst, the fundamental question we're asking is about accessibility. And this is a concept I think is actually really important to spend a little bit of time on. Accessibility basically is a measure of how long it takes you to reach any given point from another point. So basically not just from a standpoint of where can I get to in a certain amount of time, but what actual opportunities exist within that set of travel, the travel shed that's there. And by connecting this, from a time measure, where it's basically where can I get to in a certain amount of time, to what can I reach in a certain amount of time, we begin to have a conversation about what opportunities are accessible to us rather than just where can I go generally. And I think this is a really important way of thinking about mobility and transportation networks as a way of thinking about what outcomes can be achieved by accessing things using different modes and different restrictions on your travel time window or time of day that you're traveling. And this is a map right here that's actually from a project that we used, OpenTripPlanner Analyst, earlier this year in collaboration with the Regional Plan Association in New York to build basically a model of job access and workforce access within New York City. This screenshot showing basically from an origin, which is that you can see there on the right-hand side of the screen, there's a little push pin, basically showing within a 60-minute travel time window what jobs and what types of jobs can be reached using public transport and as a pedestrian. And it shows basically a breakdown of the workforce using data from the U.S. Census Bureau at a block level to show where these jobs exist. You can see the type of jobs and where those jobs are located in the region and how they relate to the transport networks. You can see, kind of corridors in which people can reach those. And this is an interactive website. You can actually go to the RPA's website and see this online and explore this data. This is being used as a way to frame a conversation about the future of transport networks and the way in which accessibility is a measure to have conversations about those future models and the way in which their current models are enabling different populations to achieve, access to workforce or access to employment, depending on which side of the coin you're looking at. And this is a kind of a static example of this, where we set up a data set, allowed people to kind of represent this as questions we kind of already framed around this sort of particular data set that we're using. This is just a kind of a blow up of this. You can see the color coding on this are the different types of jobs. There's a legend on the side that shows which industrial classification the jobs are under. And then the density here, which is like these individual points are actual jobs. The density represents how many jobs are available within that block. And this is important because we're actually not just counting what blocks you can get to, but the actual number of jobs in those blocks you can reach. And so areas that are more density obviously contribute more to the overall reach, and then areas that are further away, beyond the time window are cut off. And you can see this kind of boundary from the travel time, here, where these blocks aren't actually reachable just beyond the edge of what's walkable from the transit network that you can access from where you began the journey. And this is, again, is a kind of a single view of the tool or of this sort of analysis. But we've actually used this in a number of different ways. I want to show you a couple of examples really quickly, and then I'll dive into kind of showing where the current state of the software is and what we're trying to do to enable people to use this in a kind of a transportation planning and practitioner context. This is another example that we put together about a year or so ago in New York City, representing, this time not jobs, but population access to a given point. And this is actually showing from any given point the number of people that can reach that point within an hour. So the color scale here represents the population that can access this individual point. And you can see the brighter areas in like core of Manhattan along the major transit routes. Those are upwards of several million people. I think it's about 8 million in the brightest areas there that can reach that point within an hour using public transit. And we did this model as a comparative. This is a normal day of service. And we actually had another GTFS feed that was created as a result of Hurricane Sandy that showed the impact on service, what routes were no longer running because of tunnel closures and power outages in lower Manhattan. And this shows you the service that was no longer functional. It had been switched off, and we reran that same analysis to show the change in population access. And you can see areas that once were, the kind of core of the system were no longer functional and contributing, and they also broke the network as a whole so that people couldn't make connections across from the parts that were functional. And you can see the impact that has on the number of people that could reach the area. So in this case, population became a measure for the overall kind of health of the system and the viability of people be able to navigate New York City. This is the same map here again showing a % change in population. So in this case, the brighter areas show the highest % change in terms of the people that used to be able to reach that no longer can. This is a kind of, again, a one-off analysis where we were able to take a data set and set this up and allow people to kind of explore this question, but it required a bit of effort to actually kind of create and curate the data set. And over the last year, what we've actually been working on is turning this into a platform with a user interface that allows people that aren't familiar with the kind of software that sits behind this and the kind of fundamentals of the data that power it to actually begin to model transport systems. And this is where we are today, actually, is building out a web interface for OpenTripPlanner, and we call this OpenTripPlanner Analyst extension, which is really just another way of framing the way that OpenTripPlanner provides this information and results back to the public. With a user interface wrapping it allows you to create and curate data sets that ask these questions about accessibility. And I have a couple of screenshots I just want to walk through really quickly, and I'll jump over to a demo that shows you actually how it works and the kind of practice. But the kind of core of this is really about uploading and managing spatial data sets as inputs for accessibility measures. And the screen I have right here is actually showing you the kind of curated shapefiles that represent the access measures that we're using, in this case, jobs. This is an example of Mexico City where we've been working last year, where we loaded in a similar data set to the U.S. Census Bureau's job data set we used in New York City that had a block-level representation of jobs by industrial classifications. And so the color coding on the right-hand side matches the different sector categories, and the dots on the map, again, represent the kind of density of jobs within that system, within that network. And additionally, we have a transport layer, which is brought in from the GTFS input that was created by the city as a part of their open data program. They generated a GTFS feed for the entire transport network, and then used that we use that as the input to drive the transportation model, combining it with OpenStreetMap for the pedestrian and bicycle access. And as a result of that, we're actually able to then model very quickly, and I'll actually switch over and do this in the demo in just a second here. We're actually able to model the data that we brought in and measure jobs. And you can see here, actually, this is showing not just a single view of the system, but actually a comparative view as well. This is showing on the here on the right-hand side, we have a graph that shows the number of jobs that can be reached incrementally by minute from that given origin. So you can see a profile of how many jobs are accessible. And we also are running this query twice with a before and after with a new transport line turned on. And the area on the map actually is showing you the areas that are now more accessible than they previously were. The areas in blue actually can be reached faster, and areas in yellow are unchanged in the sense that the new transport network didn't change access. And the areas in pink here are actually areas that were not previously reachable within the time frame that we limited this to. This is a 60-minute travel time window from the origin. And under the previous conditions, you couldn't reach the areas in pink, and now because of a change in the transport system, you can reach that. And this is basically the kind of concept of what we're trying to do. I'm going to switch over to the demo because I actually have a better view of this on the demo now. I'll try to make my screen share available, and hopefully this will be visible to everyone. And we'll switch over and select. There we go. So you should be able to see on my screen now, and Stephanie or someone, if you can make sure this is working and it's visible here.
Yes, it's visible.
Great.
And then I just want to remind everybody that if you can't view it completely, please press the F5 on your keyboard to view in full screen.
And I was hoping the slides would be legible for everybody, but this may actually be better view for some folks. I made it slightly smaller than normal. So things are a little bit cramped on the screen, but let me know if there's any problem with this coming through. The transport data that I showed you, this is just really quickly. We have a couple of things that we brought in here. We have different transport layers that we're using to model the system. This is data we imported from GTFS and connected to OpenStreetMap. And then we have spatial data sets where we uploaded shapefiles, which contain thematic information like the census data or the job survey data. And those data, once they're brought in, we can just create measures. In this case, we created a job census measure, which just shows you the overall job availability or job locations at a block level within the city. I didn't break this particular example out by industry classification, but the data is actually segmented that way. And then there's, again, there's a population census here, which also shows the same representation at the block level, but in this case showing population as a measure rather than jobs. So we can use those to generate counts as part of our analysis. And there's two different ways that we're framing the analysis in the current view of the way we're doing this. One is kind of a single point, which I showed already. This will take a second to load, but I'll go ahead and set up an example here with a comparison. I'll use the job census as an example, and I'll turn on a comparative view, and I'm going to compare the baseline GTFS against a GTFS feed that was amended to contain a new transit line. And actually, we'll turn on the transit overlay here, and you can see where this amendment is showing up in green. These are lines that were added to the system, a BRT line that was proposed that wasn't in the current GTFS, but will hopefully be operating in the future. So we added that as an overlay to the GTFS and combined those together. And we give this a second to run here. I think it was taking a second before when I ran this as a demo, but we'll let it pop up just a moment here. Let's see here. I might see here. Give it a second longer. Yeah, there we go. There we go. So it's running now. So this is that example that I showed before, where we saw someone on the new line, and we could see the difference in job access between their current access to the system and the new one. You can see along the edge here where I think it's actually my internet connection is a little slow here. So I'm loading. All right, and you can see the change in the access profiles. You can see jobs are now accessible sooner in the kind of trip because they can now reach them quicker with a new line. And there's areas that are here in pink that you couldn't have reached before where those jobs were previously inaccessible within the travel time window. So this allows you to kind of quickly understand for any given point in the city what that looks like and how those changes in access affect different places. But similar to the example I showed for Hurricane Sandy, New York City, we don't always just want to show a single point, and actually that's probably in most cases not the overall goal. I think the goal is often to understand how it affects the city as a whole. And to do that, we actually run what we call a kind of regional analysis, or analysis where we basically conduct that query that I just showed you in a single point for every single location within the city. And this is an overlay that we ran previously. It takes a few minutes to run because there's quite a few points here that we're calculating. But this actually goes and calculates that representation of job access for every single block within the city and gives you a job access count within the travel time window that we're looking at. Based on the color scale here. So you can see areas in the urban core and along transit lines have higher access than areas that are on the edges of the system, both because of the proximity of those jobs, but also because of the way in which the network connects those jobs more readily. In areas along major transit corridors or high-frequency transit corridors obviously have a higher measure. This data then can be actually exported as a shapefile and made available to be incorporated into other analysis. And one of the ways that we kind of think about this view is a way to connect shape and spatial data with transport network data, and then produce shape and spatial exports that we can then take back out and share with people to incorporate into traditional or existing analysis workflows. So you can then bring the data back out and combine it with other information in the GIS context to represent this either for presentation purposes or to do further analysis. There's also some things that we're interested in doing here about using levels of aggregation, and this is a step that I won't go through. I don't think it's set up for this Mexico example, but I'll explain it just really quickly, is to say that right now we're showing individual job level access at a single block, but we actually can roll this up and aggregate this in at a regional level by defining a boundary and then using another weighting factor. For example, we could use population as a way to weight the contribution of job access. So areas with high population blocks that have high job access contribute to a weighted average for that region more than areas that are very low population but may have high access. And then we can create a single point number or a kind of aggregated number that helps us understand overall average access within that as contributed by the actual users of that, or the people originating from that. And population access to jobs is a good example, but you could really actually stand in any set of variables and you could think of that are spatially distributed and use that same sort of analysis. It could be hospital beds or schools. It could be any sort of a point amenity, and then any sort of potential access or of those amenities. And that's the way we represent this, and we use this as a kind of a starting point to then drive conversations about how change in networks affect those access measures. That's the concept I really wanted to cover for today, and I think we'll take questions at the end. But feel free to ask it when we once we wrap up the next section if you have any comments or questions about what I just presented. Thank you. And Stephanie or Martin, I guess I hand it back over to you now.
Yes, our next presenter will be handing it over to Bibiana. And Bibiana, let's see if we can get your thing up there. There it is.
Great.
Very good. All right, and with that, Bibiana will illustrate some of the things she's doing with OpenTripPlanner at their organization. Thanks, Bibiana.
Thank you. What most people aren't aware of is that in addition to the public-facing trip planners, there are systems behind the scenes that also support customer service and on-street applications. Many agencies provide a more customized service to the public for callers who may have special and or unique needs. TriMet designed the Call Taker Module in conjunction with Conveil, and it is also powered by OpenTripPlanner. It's designed to provide the call takers with as much information as possible and to retrieve it as quickly as possible, as call volumes are often very high. Before Mylene gives a live demo of these apps, I'd like to provide a high-level overview of the main functions. As a call is initiated, the call history window captures all the information about the call. And the trip options window provides the ability to enter origins and destinations, to plan specific trips which are saved, and they can be recalled or reported on as needed. Detailed info and options are returned in the itinerary window, which has features such as a high-level graphic representation about the trip, the ability to plan the first, last trip of the day, next and previous trips, and links to more details about the stop and trip viewer, and quick links to routes and timetables. The corresponding map has different base maps and functions that can be performed with a mouse or a keyboard, again, all designed so that the call takers can move and get the information as quickly as possible. Then the finalized trip can be printed or emailed to the customers. In addition, customers also request other information to be mailed to them, such as route papers, information about specific routes, system maps, things like that. Often customers will ask for these to be mailed to them, and our mailables actually automates this previously manual and very time-consuming process. TriMet also provides a service to assist larger groups, such as students, to plan the most efficient way and to manage the movement of groups on the street. The field trip request form was previously written out by hand, faxed in by the teachers, and then entered by TriMet staff. An online trip request form now automates this. And I add that I think the teachers were just as enthusiastic as our staff about this improvement. Trips can be saved, viewed, and modified. The trip options window sets preferences and adjusts the group sizes. The field trip analysis is similar to the call taker modules and allows easy management and quick features. The finalized trips are also saved. They can be printed. Receipts are also auto-generated and sent to operations for management on the street and to the teachers. I'd like to mention that all of these modules, including the public-facing trip planner, uses OpenStreetMap. OpenStreetMap is community supported. There's extensive utilization and wide adoption. It supports true multimodal trip planning, and it's worldwide, seamless, crossing jurisdictional boundaries. As more and more transit systems are emerging on the market, many of them require a readable base map, and we found OSM was a very obvious and cost-effective choice. And it now powers many systems at TriMet, including our CAD system, our fixed drop scheduling system, and our Lyft paratransit MTTs. I'll let Mylene continue with the demonstration of both the call taker and the field trip modules.
All right, so I'm going to try to connect here to our module. Both the call taker and field trip modules are web-based. Users have a login, so when they enter the system, they'll log in at the beginning of the day, and this is a view of the call taker module. As you can see, it starts with a base map, and then there are some windows that are actually floating windows, so the users can move them around on their screen and place them where it works best for them. There are tools in the gear in the upper right-hand corner, so you can turn on various tools, including the mail bowls that Viviana mentioned, and I'll just open that one real quick and start with that. So as Viviana mentioned, customers might call and request schedules to be sent to them or system maps. The users can enter in all the information, their name, their address, and then select what routes they want. So if we wanted Route 8, we can just pull it over and add it to our list. And we can pull over as many or as few routes as we need. You can change the quantity. Maybe it's a convention is visiting and they want several schedules to hand out to the participants. So we could change it to any quantity, and if large print is needed, we can mark that as well. Once all the information is entered, you just click Create Letter. It will automatically create a PDF that you can then print and process either as needed or process right away, or can set aside to process at the end of the day. And when you're done, you can just close that window. Additionally, we're viewing a base map right now, but you can also turn on aerial photography. That's available. And you can zoom in and out on your map using the buttons available or using your mouse. You can, and other keyboard shortcuts. So I'll go ahead and get started in planning a trip. You do that via the trip options box. We have several input fields, starting with where you're starting from and where you're going to. You can enter any number of items into these fields. You can use addresses, landmarks, intersections, stop names, etc. So I'm going to go ahead and plan a trip from my current office here in Portland. And I'm going to, as you see, as I'm typing, a pick list is showing up that I can select from. So the first item in the list is my address, and then also I have it entered as a landmark, so TriMet Operations Headquarters, I can pick that as well. You need to select from your pick list, and when you do, it'll put a flag on your map showing where you're starting from. And I'm going to go to our ticket office downtown. And I'm actually going to use our shortcut that we have entered, which is TTO. And now I'll put an end flag there as well. Next, you can decide if you're going to depart at a certain time or arrive by a certain time. You can then enter the time. I'm going to leave it as the default time in the system right now. You can change the date as well or keep it as the current date. If you want to, as you can see, my time is a little outdated, so if I want to plan my trip from now, I can just click the Now button and it will update everything for me. It defaults to traveling by transit, but you can select a variety of modes. If a customer only wants to ride rail, you could select rail only, or if they want to include a bicycle in their trip, you could select bicycle in transit. We have a maximum walk set at ½ a mile, and this is for the trip as a whole, but it can be changed. You can either enter a new maximum walk, maybe the customer is willing to walk up to a mile, or you can use the presets to change that as well. You can also set preferred routes. If a customer prefers to take the green line over riding line 72, as an example, you could set that through this user interface by pulling over the route in interest that the customer is requesting and then saving that. You can also ban routes the same way, and when you ban a route, the system will plan the trip as if that route does not exist at all. So I'm going to go ahead and plan my trip right here. So I click Plan Trip, and you'll notice two things happen when I did that. We have an entry in our call history box, and we also got our itineraries back. It usually defaults to 3 itineraries, with the best itinerary showing the details for the best itinerary. Each itinerary has an at-a-glance summary of the trip with the start time, the modes of transit, which are color-coded, gray for walking, green for bus, red for rail, and blue for cycling, and the start and end times of the trip. And then within each itinerary are the details for that particular trip. As you hover over the elements, you'll notice on my map it's highlighting in yellow that portion of the trip. You'll see that the walk portions are collapsed and the transit portion is automatically expanded. If we wanted details on the walking portion, we can just click on that header and it will now give us the details. And as we hover over each element within, it will show us on the map where those are. Within the transit element, there are several tools, including a stop viewer and a trip viewer, and if there are any service alerts in effect, that shows as well. You can click on the link of the alert to take you to our website, or you can just expand it and read the details of the alert. At the bottom of every trip is a trip summary showing you the travel time, how long you're in transit, your total walk distance, and what any transfers and what your fare is. This is also where you're able to print or email your itinerary. Going back to this particular itinerary, looking at a couple of the tools, the first tool is the stop viewer, which allows you to see all of the scheduled stop times for that particular stop. It shows every route that serves that stop and what times that they are there. So if a customer is wanting to know when the next line 19 is coming after the one in question, they can go through the stop viewer and see that, oops, I need to go a little forward in time, sorry about that. So after the 9:44, the next one is scheduled at 10 a.m. Additionally, we have a trip viewer. Oftentimes, customers who are unfamiliar with our system or unfamiliar with their destination, the area around their destination, want to know what the stop or two before where they're getting off are. So the trip viewer enables our customer service representatives to easily provide that information. The trip viewer shows all of the stops on the trip in question and highlights the ones that are involved in this particular itinerary with an arrow showing where you're getting on and then an arrow showing where you're getting off. So if the customer wanted to know what the stops right before their deboarding place at 6th and Yamhill are, we can look and see that 6th and Jefferson is the stop before. Additionally, within the trip viewer, we can get real-time stop information, we can recenter our map on that particular stop, and we can also open the stop viewer from here as well. we have a lot of interconnectivity throughout this system, so you don't always have to cycle through and go to a certain spot to find the data you want. We make it available in several different locations to assist our representatives. As Bibiana mentioned, also from the trip viewer, you can link to our website, which has our route. You can find the route information and also get directly to the route schedules in question. You can also get to that schedule from the trip viewer as well. Additionally, Bibiana mentioned you can get the first trip of the day, the last trip of the day, and also view previous and next trips. You can, if you care to see a different itinerary, you would just click on that itinerary to see the details for that particular one. Let's see. So when you're done with the itinerary, you can either close that box or you can click End Call. Or if the customer wants to also plan their return trip, you can leave your call going, and then over in your trip options box, we have a little arrow that you can click, and it flips your start and end point, and then you just change what your departure time is. Say we're leaving at 3 p.m. now to return, and we can plan our trip. Now we have a new entry in our call history box, and we have our new trip plan. If once you provide that information to the customer, if they have a question on the first trip plan, you can go back to your call history box, click on the previous trip plan, it will replan it for you, and you can provide that information. Say, for example, they couldn't remember what time they're supposed to get off at 6 in Yamhill. We can go back and tell them it was 9:56 a.m. Additionally, when we finish a call, you can click End Call. It adds a new entry into our recent call list and clears out our trip options box so we're ready for the next call. Additionally, within our map, we have other tools that I'll show you real quickly. So I zoomed in here, and now you can see our stops in the system. You can click on the stops to get more information. Everything that's underlined is a link. So the stop name, for example, will take you to a stop landing page where you can get information for the stop, including what amenities are there. Sometimes customers want to know if that stop has a bench or a shelter, so we can look and see if it does. You can also get next arrivals and schedule information from this page as well. Additionally, you can go straight to the stop viewer and the real-time arrivals page, as well as start a trip plan. If the customer decided they wanted to plan a trip from that point, you could just click From Stop, and it will automatically fill in your trip options box, and you can continue from there. I'll just really quickly show you a couple things in the field trip module, and then we'll open things up for questions. So moving on to the field trip module, we have that here as well. And it's the same basic view, except for they have a field trip request box. We have a place for the new requests come in, a place for the planned trips, any that have been canceled, and then those that have occurred in the past. To pull in any new trips that might have come in since the user has been working, they can click refresh request, and that will pull in any new trips that are available. Bibiana mentioned that we have reports that we can send to operations so they know what field trips to expect, and that is this daily report down at the bottom. It defaults to the next day, because each day, at the end of the day, we would send an email to operations with the link to the report for the next day so they can prepare. You can also view it from here. Again, it's online, and it shows you a breakdown of each field trip, what route they're using, where they get on, where they get off, and how many students to expect on those trips. Within each field trip, we have various items for both internal trip planning use and just also internal accounting use. And I don't want to plan a trip right now because I don't want to mess up anything for the person who's planning trips right now, but that's essentially how it works. I will find one that has been planned, so I can just show you really quick. It'll fill in the outbound and inbound trips, and we can do a printable trip plan, and this would be sent to the teacher so that they can see all the information and directions for their trip. It's very similar to what you would do if you were printing a trip for the Call Taker module. So that's a real quick introduction to the trip planner and the field trip module, and now we'll turn it over for questions.
Great. Thank you very much. That was really wonderful. We have a couple of questions that I'd like to address. Some are, it's not clear who it's for, but the first one I know it's for Kevin at Convail. And it's a question about how you are averaging over time the accessibility measure. Since transit availability is constantly evolving, have you done a brute force calculation over each minute during a time window, or have you found a more clever way to find a sort of, quote, average or, quote, typical level of accessibility?
That's a great question, and it's actually something, I should have actually covered in the presentation. This is actually an area where over the last 6 to 8 months or so, this has been an area we've spent quite a bit of time working on, actually. The question, just to be really clear so everybody understands, is that as variability in service changes, especially in low frequency service, your departure time actually changes your accessibility in quite a significant way. So, for example, if you leave a minute after the bus, goes by in front of your house, the accessibility of things from your house is extremely different than it was the minute previous when the bus was pulling up. And so the averaging question really is about how do you kind of create a number that represents the service as the kind of periodicity of vehicles along the network changes your accessibility. And what we've actually done is actually built a model where we actually can query a time window and get back with a single request and a single representation that takes the same amount of time as the individual trip plans, the average service, including the changing headways over that service window. And historically, this has been done by actually making multiple queries and then taking the numbers and combining them together. That's extremely computationally intensive. But in OpenTripPlanner now, this is available also for individual trip routing. You can now make a query that actually lets you get back a representative sample over a time window that incorporates that average representation, and it's just as fast as doing a single trip plan. And that's something actually, as we talked about on its own, the kind of ideas and issues behind there, because it's extremely powerful way of looking at it both for individual travelers as well as for accessibility. And we actually think, in terms of going forward, that that's the only correct way to represent accessibility, because if you don't give that your departure time basically determines the outcome of the answer you're getting.
Great, thank you. We have another question for Bibiana and your team regarding the functional. So for Bibiana, it's great to see all the trip planning functionality on a desktop browser. Is there an opportunity for a mobile app, or does it exist? I guess it's not just for Bibiana, but also for the Convail folks that are working on the development.
For the trip planning and call taker modules, there's not really a need to access this information from anything other than a desktop. We have quite a few mobile applications out there, third-party applications that are actually using our APIs and using OpenTripPlanner, and we're seeing more and more of them come out, such as Nimbler, the Transit app, and there's more. And we are working on a trip planner application that is mobile.
Yeah. Okay, great. Great. I guess also for Bibiana and your team, and also Convail, we have a question regarding when will other agencies be able to implement this technology? I know it's in the open source. Is it available? I'm sure the presenters are looking for either cooperation with Convail or the ability to download the information for the application themselves. I'm not sure who would answer that. Kevin,
so is that referring specifically to the call taker features or the accessibility tools?
I think, well, I'm not really sure. They didn't clarify. I'm going to guess that it's the call taker.
It's the same answer for all, actually. Really, they're all open source. I mean, all the code that we've written as part of OpenTripPlanner, both at Conveo and a number of other developers around the world, including colleagues at TriMet's that are actively involved in contributing to the platform. All of that code is available to download and use. And there are people using it independent of Conveo's involvement. Actually, quite a few of the examples commercially are companies that have built platforms on top of that, and there are also transit agencies and operators around the world that use it. What role we play in it is actually really supporting the development of it and supporting users that want assistance with that. But the code itself is available and is without a license. It's open source.
Okay. That actually answers another question someone asked is who owns the software? So it's in the open source, so it's available for anyone to download the information from a GitHub or something along those lines.
Correct. And for OpenTripPlanner and the kind of core OpenTripPlanner code, the license on that is actually held by a nonprofit, the Software Freedom Conservancy, which basically manages the intellectual property for that in trust and holds it in trust so that all of the stakeholders that contribute to the project know that they have equal rights and kind of representation within that. And Conveo is one among many stakeholders in that project.
And also might add that in addition to European countries that are providing implementation and support services, there are companies in the U.S. that are emerging to provide implementation and support services in addition to Conveo, such as Trillium Transit, Cambridge Systematics, IBI Consultants, and a couple others. So.
Great. Someone had a question. It's not 100% clear. They're asking about, is there a way to analyze user benefits for a proposed project using this system similar to the FTA Summit program? This seems like a great tool to show potential decision makers. I'm not familiar with the FTA Summit program, but are there other user benefits that could be evaluated based on what we currently saw?
Yeah, I think that actually is exactly the goal. I mean, one of the main ways in which we've seen the analysis tools used to date is to actually do A/B kind of comparisons on the proposed systems. And really, all that's required as an input for that is having a GTFS feed that presents the system as it's proposed. And I believe, if I'm not mistaken, that the FTA program, at least what I might understand how it's evolved over the last year or so, is that they're now requiring agencies to submit GTFS feeds representing new start projects. In that case, you actually have GTFS feed actually allows you to create a model. And something I didn't get into it for purposes of time, and it's actually a bit more complex. There's a lot of different paths to this. We also have tools available at Conveo, and as Viviana mentioned, there's a number of other organizations like Trillium Transit that have tools available that help you produce GTFS. So if you don't have it already in hand and you don't have the technical capacity in-house to produce it, there are options available to actually creating those GTFS feeds to represent both current and proposed service. And once you have those two, the before and after, then the sort of comparative view of what the impact of a proposed project is actually kind of fundamentally what we produce.
This is David from Conveo. One thing I'd just add to that regarding Summit, I think this is actually a good example of how these accessibility tools can kind of broaden the set of metrics that we're using to evaluate these projects. I worked with the Summit model some when Martin mentioned earlier that I used to work at the MPO in Atlanta. And in my experience, what Summit primarily did was kind of act as a post-processor to the more traditional demand models, four-step models, and that sort of thing. And the user benefits were expressed primarily in terms of travel time savings as a result of building a new transit project compared versus the baseline. And I think that's a valuable indicator to use, but there are certainly a lot of different ways of looking at the impact of these projects. So in addition to travel time savings, you can also look at accessibility and how does a project increase your access to jobs or other community resources. So I think this is a good chance to really have it broaden what we're looking at there. And given that FTA is now embracing the GTFS data standard as a component of this analysis, that really allows for these sorts of tools to kind of augment what's traditionally been done there with those existing tools like Summit. So that's certainly something I think we want to see evolve going forward.
That's great. Actually, we have another question regarding both to either Kevin or David regarding the source of the employment data. I'm guessing it's LEHD, but they're wondering where did you get the data at the block level in the example shown?
For the example from New York City, and actually all the work we've done in the U.S. we use LEHD data from the Census Bureau, which has block level industry classification, workforce classification. And then similarly, for the example I showed in Mexico, there's a national job census that has point location data for every job in the country, and we aggregate that at a block level.
Okay, for those of you who don't know, LEHD is a census product from called the Longitudinal Employment Household Dynamics data set. That's an administrative record set that, as Kevin was articulating, shows the job locations based on administrative records. Let's see. Oh, I guess a follow-up question is, are there other demographics that could be weaved into the network analysis tools, such as income or population? I know does the tool allow for other demographic data to be evaluated?
Yeah, it definitely does, and the examples we've shown have largely relied on job and population because it's an easy story to talk about in terms of what's being measured, and also because there's these uniform data sets like LEHD, we can actually do that same analysis across the country without having to find input variables that might be unique to that location. However, one of the main applications that we've been interested in seeing this tool used for, I don't think we have a good example to point to yet where it's been fully explored, are kind of Title VI and transport equity kind of conversations where a much richer kind of profile of kind of who the ridership population are and what the opportunities and the access are would really be smart to bring in. And the tool is designed so that if you have a spatial variable that you can represent as a point or a thematic source in a polygon, you can bring that in and use it. And we're kind of like you could say data agnostic in that sense. You can pick the variables you want as long as you have the data to support it. The one thing I think is important to talk about in terms of accessibility, though, is that the more precise the spatial resolution of those variables, the better results you're going to get. One of the challenges we run into when you look at other variables that are, often of interest in those sort of conversations is they happen at a coarser geographic scale, and that means that we actually can't measure the accessibility within that kind of defined region as precisely because we don't know where those things are distributed at, say, a census tract level. And the accessibility across the census tract might be quite significant. Variability and accessibility might be quite significant. So if you can get that data at a block level or thereabout, then pretty much anything can be brought in. And if it isn't available at block level, then you have to just take into account that the precision will be reduced.
Great. Actually, we have another question about to Viviana and your team with the call center app. Is what methods do you use to send the itinerary? Is it email, PDF, and hard copy alone? Is it possible to host a temporary web page and send a link to the page via SMS?
Okay, all of those methods can be used to send the itinerary. And with regards to a temporary website for SMS, anything's possible. That hasn't really come up, though, and a lot of the callers who are calling in, quite often they don't have access to a computer or they're not tech savvy. I might also quickly answer the question about Street View. You can access Street View via clicking on our stops on our public-facing application at ride.trimet.org. However, for internal applications, we're not able to use Street View and link to it due to their licensing in terms of use agreement. We do have 3-inch aerial photography for the region that's flown annually through our annual photo consortium.
Great. Yeah, thank you for that. Was our last question. Except we got one more. We'll add in before. Some of you will notice that there's a link for your feedback on our presentation. While we answer this last question, feel free to rate how we did today. It helps us improve our program. I guess one last question: is it possible to use non-transit data such as van pool schedules as part of the commuter-focused implementation of this software? I guess that's kind of a question to anyone on the panel.
Actually, David, do you want to take that, given the work you're doing right now? Do you have David still?
Yeah, sure. Sorry, I was muted there for a second, but yeah, that's something that hasn't traditionally been included in OpenTripPlanner, but we're actually looking pretty actively at expanding to include information, such as carpool example information. Obviously, we're talking about a service of a slightly different nature here in terms of the scheduling. Is going to be it's going to be a little less structured as what we're used to working with GTFS data, but I think it is something that we're looking to add to the general platform. In order to do this in order to support the accessibility-based analysis, I think there's going to have to be some adaptation of some of the techniques we're using to account for these more flexible schedules. But it is something that we're actually looking at. We're doing a project here in the Washington D.C. area that's looking at bringing together all of these various options: transit, carpool, biking, rideshare, all into a single platform. So I think kind of a logical next step there is looking at extending that to to some of this accessibility-based work that we're also doing on top of the OpenTripPlanner platform.
I also might add that we did a pilot early on with Zipcar, and on our public-facing map, customers were able to plan trips using transit or bike or walking to actual Zipcar locations. We're working with Zipcar, Car2Go, many others on really developing a standard to facilitate more applications like this and make it easier for the developers to get access to that information.
Great. Well, thank you. Actually, Viviani, you also answered the last question there for us that popped up right when we were wrapping up. I know everyone is doing this. Well, not everyone, because not everyone's on the East Coast, but is taking time off from their job or during their lunch break. We want to respect everyone's time here. And I want to thank our speakers. And it was very informative. Everyone should know that we will pass along a link to the recording of the presentation. And if there are any follow-up questions, please feel free to contact us, and we will forward those questions along to the presenters so that we can, they may be able to address it individually if possible. And with that, I'm happy to wrap up our CUTR cast. I want to thank all of our speakers, a wonderful presentation, and wish everyone a great afternoon. Or I guess morning if you're on the West Coast. Thank you.